Again, a local Chicago startup funded by Hyde Park and a few other local VCs, but I'll let Roy give a quick intro on the company.
Hey everyone, coming in this snowy day. Nice to meet everyone. My name is Roy. I'm the co-founder and CEO of Definity. Before we start, just to kind of get a little bit of a sense of the room, how many here is data or ML engineer? Raise your hands. Okay, so maybe data scientist. You, product people. Great. Anyone else in analytics? Fantastic. So great. Definity is a data pipelines observability solution that's designed exactly for people like you in advanced data engineering teams, and we'll talk about it in a second. Definity really started out of our own experience and necessity. I came more from the product and data side. And the years did work with McKinsey and did a lot of product data work for enterprises that wanted to go more into personalization, how to actually leverage the power of predictive analytics. A few years back, my co-founders came from the core data ML engineering work at PayPal. And what we found, we literally looked and experienced the same problem from two different sides. And the problem was that when you have massive scale data platforms doing all sorts of crazy things, from fraud all the way to personalization and micro-targeting, data breaks. And the problem is that data engineering teams are developing code that's essentially software that the company in this day and age runs on, mission critical software. But this software is not being monitored, not being measured. More importantly, the outputs are not being measured. So things break, and as long as you can catch it, that's fine. But what happens when your customers catch it? Or when your CMO that's looking at your marketing spend dashboard is looking at something, and all of a sudden there's a glitch, and your entire company spent another 200K last week, something that they should. So that was our own personal experience, and this was the necessity. This is what we're trying to actually solve. Oh, thank you. Sorry, I should have done it before. Great. So the problem is that, again, maintaining data pipelines in production is becoming extremely hard. Companies, lose at the end of the day money for that, both in terms of lost revenue and in terms of lost productivity for their data teams. And maybe more important for the people here in the room, we lose time for that. We waste time on firefighting issues and writing tests that are super manual and mundane, and just doing stuff that are not bringing new value to the company, not developing new business logic, not developing new models or pipelines. And the problem is that when you start small, or if your use cases are mainly around analytics, BI, you can probably get away with it. The problem becomes when you start developing very complex pipelines, graph analytics, entity resolution, talking about pipelines that maybe run daily, for 8 hours, over millions of transactions that happened yesterday. When you start doing those things that are a little bit more advanced in terms of predictive analytics, when you're starting to do things at scale, when you're doing things that are mission critical for the organization, meaning if something fails within a couple hours, you start getting an email storm of what's going on. And especially if you're working on the I would call it trivial data platforms in the cloud. So if you're working maybe on-prem, or working especially on Spark, that's becoming very complex. It's becoming very hard to maintain and to actually understand what's going on. And what we are hearing from folks that we are working with is, there are thousands and tens of thousands of pipelines running in production every day, and they don't even know if they succeeded or not. And you just hope that the data is where it should be. So this is the absurdity here that we were kind of tried to solve. And I think I spoke to most of those, but just to give you kind of a flavor of the idea, we're talking about, when we talk about pipeline, we're talking about the actual transformation happening in the data platform. So we're not talking about the ingestion part, we're not talking about the business application, modeling, beyond the feature store, the BI itself. We're really talking about those transformation happening, again, within Spark, on dbt. And if you don't have visibility, you start catching bad data too late, after it hits consumers. When you already caught an issue, there's zero understandability of where did it start. And now root cause analysis is becoming a long effort, a blame game between teams. Who changed something upstream? Okay, so what are teams doing, right? Well, the first thing to do is to start writing data tests, right? You're expecting a certain data to be the output of the pipeline. You know what the volume should be. You know how fresh you want it to be. You know what distribution you might have. So you're writing those tests. The problem is this is super manual, and when you have thousands of pipelines in production that keep changing, it's not scalable. Coverage is low. We all hate to do that because who wants to write tests? And you know what? Even if you write a test, it's static at the end of the day, and it's not dynamic. So this is where we come in. And Definity essentially is an automated data pipeline observability platform that really sits on top of the query engine, Spark, dbt, etc. And really provides 5 key pillars of full end-to-end observability. It provides holistic monitoring, not just of the data, but of the data and the pipelines itself, the code, the infrastructure that it runs on. It provides automated coverage. No more writing manual tests. No more changing thresholds. Everything is done automatically in post-production. It provides proactive protection. It runs in real time, not after the fact, sampling the data, looking, after the fact, say, hey, are our results good enough? It runs in real time and therefore can detect anomalies in real time and preempt, preempt pipeline runs in real time. And then provide a full context around the runs, the execution, including lineage in Spark, which is pretty hard to do, including code changes, environment changes, schema changes, things that are really hard to track across different runs, but you need them in order to solve, and root cause issues really quickly. And lastly, it even looks at the infrastructure from a cost perspective and can help you really find those optimizations on the pipeline level in terms of performance, SLA, unused resources, CPU utilization, etc. So let's see how it actually works. So if I'll jump here, obviously every good platform needs to start with a good dashboard. So, but I think the main point here is that the unique thing about Definity is that it monitors both the data and the pipeline's health. So you can see that here on both sides, not just the output, but actually what's going on and what's flowing through the pipes. And here so we see like a broad overview of the coverage and health of the system. But if we dive into the pipeline section, this is where the interesting stuff begins. So this is an example, by the way, it's an NBA public data. This is an example of all the pipelines that are running in the system. This lineage was automatically discovered and built by the platform.
Zero user config. No need to tag anything, no need to input, no need to work with the data catalog. Zero user config. This was built automatically. Not only does it show all the pipelines in the system, but if we click on a specific pipeline, you can see here that it goes internally into the pipeline and split it up to the specific tasks and transformations that are combining from it. More than that, it doesn't only show you how data flows. It shows you what specific tasks or code generated each data set. And that's very, very strong when, again, you understand that there is a problem in the data set and you can see exactly what code created it to the transformation level. Not to mention the specifics around, for instance, if we'll go to player init to a specific task here, you can see parameter changes across different execution runs, how the environment changed. You can even see code and code changes across runs. You can see schema changes. So those are very strong capabilities to have. Again, all automatically built and created in runtime in order to root cause issues. But the question is then become, okay, you can root cause an issue after you detect it, how you actually detect an issue. So this is where Definity, if you go here to the pipeline again, this is where Definity, as I said earlier, automatically creates a full, let's for instance search for maybe college or college. Let's see what we have here. There's anything interesting. This is where Definity creates metrics across all different metrics across the board, both for data quality in terms of volumes, distribution, schema, freshness, and also in terms of execution. So as I mentioned earlier, you can see here execution pipeline-related metrics in terms of SLAs, durations, statuses, even CPU utilization. So you can see here, for instance, you can see actual memory time that is being used by each transformation, in this case a task, that we can then track over time. Now, not only do we track all of those metrics out of the box without the user having to configure anything, and again, you see here, just for this run, we tracked 579 different metrics. We generate tests for each of those. So if we'll see here, for instance, let's see something interesting. Okay, so we see here at a specific metric, we learn the baseline over time, over the first few ones. We automatically generated a test to detect anomalies with this metric. And as you can see here, the last two runs, an anomaly was detected. Again, all of this is done in real time. So the anomaly is detected. The anomaly is detected actually before the data is written. So Definity runs before any read and before any write operation on input data, interim data, and output data, and therefore can even detect the issues before they are written and propagating downstream in your system. That's huge because then you can avoid reruns, you can avoid backfilling. We all know probably that it's pain that we don't want to handle. Lastly, I'll just show here something pretty cool. Obviously, the user can edit the test, fine-tune it if they want. All done in post-production. Done are the days where you have to go back to the code, change some thresholds, redeploy, pray to God that nothing breaks. You can do everything here in post-production. Plus, as I mentioned earlier, you can have a circuit breaker, a preemption, meaning next time that this will run and raise an alert, the pipeline itself will break. And the strong thing about that if you think about it, again, I mentioned that those are can be huge pipelines that run for 6 hours on millions of transactions from the previous day. It's a huge benefit if you can stop the run before it even starts. What we see today that with many of the enterprise organizations we work with is that their problem, the plague of reruns, is huge on their cost. A lot of waste in terms both of orchestration and timing of how do you actually run those pipelines, cluster utilization, reruns. If you can do all of that, track duration, track SLAs, understand issues before the run even starts and preempt them, that's a huge opportunity for cost savings. I know we're almost out of time, so I'll stop here. Just wanted to leave room for a question or two. Yeah.
Curious what the actual implementation